Welcome to the deep dive. Today we're tackling a really big idea in theoretical physics.
The theory of everything.
Exactly. That single theory that could finally unite quantum mechanics and general relativity, our two best descriptions of the universe, but they just don't play nice together.
It's a fundamental clash, isn't it? Quantum mechanics is fantastic for the super small atoms, particles.
Right.
And general relativity nails gravity, black holes, the whole cosmos scale. But they break down where things get really extreme.
Like inside a black hole or right at the Big Bang itself.
Precisely. The math just goes haywire.
We actually talked about one attempt to fix this before superstring theory. We did a deep dive on that.
Yes, superstrings. Very elegant mathematically.
But it comes with some, let's say, interesting requirements, like, what was it, 11 dimensions?
11 dimensions, that's the common number. And the problem is, well, we haven't exactly found them.
Understatement. That lack of evidence is a big reason why people are looking elsewhere.
Absolutely. And that brings us to today's topic, loop quantum gravity. It's another major contender.
And what's really grabbing headlines about loop quantum gravity, or LQG?
And well, one of the most striking things is, unlike strings, it doesn't seem to need all those extra dimensions. It works fine in our usual 4.
Okay, just 4 dimensions. That already sounds a bit more grounded.
It can even suggest fewer dimensions at the most fundamental scales, which is, well, counterintuitive.
Fewer? Whoa. Okay, hang on. We definitely need to unpack that later.
We will. But the point is, LQG isn't just about dimensions. It's aiming right at those weak spots in our current theories.
The black hole singularity, the very start of the universe.
Exactly. Places where quantum mechanics fails because it doesn't really handle gravity properly in its standard form, and where general relativity fails because it predicts these impossible infinite points, singularities.
So gravity is the sticking point. It's the one fundamental force we haven't managed to quantize, to fit into that quantum framework.
That's the core issue. Without quantizing gravity, we can't fully describe the Big Bang's first moment or what truly happens inside a black hole.
Which leads us right to the main question for this deep dive.
Yeah.
What exactly is loop quantum gravity, and why is it generating so much buzz right now?
Let's dive in.
Okay, so foundations first. What are the basic building blocks of reality, according to LQG? What's everything made of?
Okay, this is where it gets really different. LQG proposes that space and time themselves aren't smooth and continuous like we experience them.
Not continuous.
No. At the very smallest scale, they're made of tiny, discrete, indivisible units. Think of them as atoms of space-time.
Atoms of space-time. Not particles in space, but space itself is chunky.
Essentially, yes. They're often called quantum loops or quanta of space-time. They're like fundamental excitations of the gravitational field.
Wow. Okay, so if space is made of these loops, how do they form, the universe? Do they connect?
They do. They link together, weave into this incredibly complex network. Sometimes it's called a spin network or quantum foam.
A spin network. Like a fabric.
Exactly like a fabric.
Yeah.
This network is the fundamental structure of space. And things we think of as geometry, like area or volume, they actually come from the properties of these loops and how they connect. They're quantized, too.
So even volume comes in minimum chunks. You can't have a volume smaller than a certain amount.
That's the idea. There's a fundamental minimum size.
Okay, my mind is slightly blown already. How does this incredibly tiny, discrete network create the smooth world we see? Matter, energy, time flowing.
Think about a TV screen or your phone display.
Okay. Pixels.
Right, pixels. It looks like a smooth, continuous image, but get close enough and you see it's made of tiny individual dots. In LQG, you can think of each quantum loop as a sort of pixel of space-time. And the state of that pixel, its energy, how it's connected to its neighbors, that determines what's happening.
So the whole universe is like a giant quantum display. And everything we see, a planet, light, me talking, is just patterns changing on this display.
That's a powerful analogy, yes. Changes in the color or brightness or connections of these quantum loops manifest as everything we perceive.
Let's use that screen analogy again. If you see a car driving across the screen at the pixel level, it's not really a car moving. It's just pixels turning on and off, changing color in sequence.
Precisely. And LQG suggests something similar for reality. What we perceive as, say, an electron moving through space might fundamentally be a pattern of excitations rippling through this network of quantum loops. One loop turns on, the next one turns on, the first turns off, creating the illusion of smooth motion.
Which implies, does that mean matter itself isn't fundamental? Like electrons and quarks aren't the bottom layer?
That's a really sharp insight. In this framework, the most fundamental things are the loops, the quanta of geometry, the excitations of the gravitational field.
Right.
What we call matter and energy are more like specific kinds of patterns, knots, or localized disturbances within that fundamental quantum geometry. They aren't separate things sitting in space, they're features of space-time itself.
So it sounds like everything boils down to information. The state of the loops, how they're connected.
Yeah.
Is that the idea?
There's a strong connection there. The fact that space-time is discrete means any region can only hold a finite amount of information. This links up with ideas like the holographic principle that information about a volume might be stored on its surface.
Interesting.
LQG doesn't explicitly say we live in a simulation, but it definitely points towards reality being fundamentally informational. The states and relationships of these loops are like the universe's fundamental bits.
Which brings us back to why physicists are so interested. We know superstring theory tries to unify forces. What problems is LQG specifically trying to solve?
Its main appeal is tackling those points where our existing theories just give up. The Big Bang singularity, the heart of black holes. By quantizing gravity, by making space-time itself quantum, LQG offers a way to describe these extreme environments without infinities cropping up. General relativity predicts infinite density, which is basically the theory saying, I don't know. LQG potentially smooths out that infinity, providing a description of what happens at the Planck scale, the smallest possible scale.
Okay, that sounds incredibly promising. So what's the holdup? Why isn't it the accepted theory yet?
The biggest hurdle, honestly, is testing it. Like a lot of quantum gravity theories, the effects it predicts really only become significant at incredibly tiny scales and enormous energies.
Scales we just can't reach with current experiments, like the Planck scale you mentioned.
Exactly. We're talking energy levels vastly beyond even the Large Hadron Collider.
Yeah.
So finding direct, unambiguous experimental proof is extremely difficult right now.
So it's in a similar boat to superstring theory in that respect. Great ideas, mathematically compelling, but waiting for that killer experiment.
Largely, yes. Both are beautiful theoretical frameworks trying to solve fundamental problems, but proving them right, that's the challenge.
You said earlier, though, that if LQG is correct, it has a really profound implication for reality itself. Can you remind us what that was?
It really forces us to reconsider what reality is made of. If LQG is right, then the fundamental layer isn't smooth space or tiny particles moving around in it.
Yes, the loops.
It's the network of discrete loops. Reality is fundamentally granular, informational. The continuous world we see is an emergent property arising from this deeper, discrete structure, not continuous matter, but quantum information.
It's amazing how this search for the fundamental keeps pushing us into stranger territory.
Yeah.
This whole idea of finding the ultimate building block, that's an old quest, isn't it?
Oh, absolutely ancient. You can go back to the Greek philosophers like Democritus.
Atoms?
Exactly. His idea of atomos, uncuttable, indivisible units that make up everything. That basic impulse to break things down to find the smallest part has driven science for centuries.
From atoms to protons and neutrons, then quarks. We keep digging deeper.
And the motivation is always the same. What is this stuff really made of? If we find the smallest bits, maybe we can understand the rules that govern everything.
But Democritus himself saw a philosophical problem with dividing things forever, didn't he?
He did. He worried that if you could keep dividing matter infinitely, you'd eventually reach nothing. Size zero.
And how do you build a universe out of an infinite number of zeros? Doesn't make sense.
It's a paradox. How does something substantial emerge from infinitely divisible nothingness?
So how does LQG deal with that paradox?
By saying the division stops. You can't divide space or volume infinitely. You hit a fundamental limit, the scale of these quantum loops.
The pixels.
The pixels, exactly. They're the indivisible units. So reality has a smallest scale, a fundamental graininess. It avoids that slide into zero.
And this applies not just to matter, but to space and time themselves. They come in chunks.
That's the core idea. Space isn't a smooth stage. It's built from these discrete units. Time doesn't flow continuously. It ticks forward in unimaginably tiny steps. Area and volume are also quantized. They only exist in specific, discrete amounts.
Okay, if time ticks in discrete steps, why do we experience it as this smooth, continuous flow? It certainly feels continuous.
It's a question of scale. Those fundamental ticks of quantum time are incredibly, incredibly small, far smaller than anything we can perceive directly.
Like the frames of a movie.
Exactly like that. A movie is just a sequence of still pictures shown very fast. Our brains perceive smooth motion. Similarly, the quantum ticks of time happen so rapidly, and there are so many events at that level that our macroscopic perception smooths it all out into what feels like a continuous flow.
We're seeing the movie, not the individual frames.
You got it. We perceive the large-scale image created by trillions upon trillions of these quantum pixels doing their thing, not the pixels themselves.
Which, of course, brings up the big question. Where do we fit in? Consciousness. Does LQG say anything about awareness in this quantum pixel universe?
That's really getting into speculative territory, far beyond what LQG as a physics theory currently addresses. It's focused on quantizing gravity, the structure of space-time.
But the implications are tempting to think about.
Oh, definitely. If reality is fundamentally informational, it opens up philosophical questions. Is consciousness somehow related to how this information is processed? Could awareness exist somehow, separate from the screen itself? Like a VR user.
Like we're experiencing this quantum reality, but maybe aren't entirely part of its fundamental code.
Maybe. Some fringe ideas even talk about higher dimensions or external programmers, but that's way outside mainstream physics and LQG itself. It's crucial not to confuse LQG with, say, subjective idealism, the idea that reality is just in our minds. LQG proposes an objective, discrete reality made of loops. We just perceive it.
Right, important distinction. Okay, let's go back to firmer ground, the Big Bang. How does LQG change the picture of the universe's beginning? No singularity.
It offers a potential alternative. Instead of everything starting from a point of infinite density, the singularity, which is where general relativity breaks down, LQG suggests something different.
What's that?
A quantum bounce. The idea is that the universe might have been contracting before the Big Bang.
Contracting. Like a big crunch.
Sort of. It contracted down, getting denser and denser, but instead of collapsing into an infinite singularity, it reached a minimum possible size dictated by the quantum nature of spacetime, the Planck scale.
The smallest possible pixel size.
Right. At that point, quantum gravity effects would become overwhelmingly strong, and instead of collapsing further, they would cause the universe to, well, bounce.
Bounce back outwards, starting the expansion we see today.
Exactly. It avoids the singularity entirely. The universe deflates to a minimum quantum volume and then inflates. It's less an explosion from nothing, more a rebound from an incredibly dense quantum state.
That sounds weirdly like some old creation myths. Primordial chaos, then structure emerging.
There are some interesting resonances, perhaps. A state of maximum compression giving way to expansion and structure formation.
So, in this LQG universe, what's the most fundamental stuff? If it's not matter or energy in the usual sense.
It's information. The information encoded in the quantum states of the loops, their connections, their geometry. That is the fundamental reality.
And time.
Time itself emerges from the changes in this network, the sequence of quantum events. It's not a separate river flowing. It's more like the clicking of the universe's fundamental clock, derived from the relationships between the loops.
And space is just the network itself, the way the loops are arranged.
Precisely. Space isn't the box, it is the structure formed by the loops.
Okay, one last visit to that virtual world analogy. It keeps popping up because the description, discrete units, information, emergent reality, sounds so much like a simulation.
The analogy's tempting, isn't it? A reality built from fundamental bits, processed to create what we see. It definitely echoes digital simulations.
But you're saying the physicists working on LQG aren't trying to prove we live in Matrix.
No, not primarily. Their goal is to solve deep problems within physics. Quantize gravity, unify the forces, understand the Big Bang. The fact that their proposed solution looks a bit like a display or simulation is more of a consequence of describing space-time at its most fundamental, discrete level.
It's an outcome, not the starting point.
Exactly. The display analogy helps us visualize the implications, but the core physics is about quantum geometry.
And if someone asks, well, if it's like a display, why can't we see glitches or anti-gravity?
The LQG answer would be that the rules programmed into this quantum network, the fundamental laws emerging from these loop interactions, are consistent within our observable universe. Maybe anti-gravity isn't part of the code for our patch of reality, or maybe the operators, if they exist, just haven't enabled it here. But that's pure speculation again.
Okay, got it. So let's try and wrap this up. What's the key takeaway from loop quantum gravity?
I'd say it's this radical idea. Our universe, at its deepest level, might be a network, a dynamic web woven from discrete quanta of space and time.
These quantum loops.
These quantum loops. And everything we experience, matter, energy, the smooth flow of time, the geometry of space emerges from the collective behavior, the information encoded in this fundamental network.
And it offers a potential path to solving huge physics mysteries, unifying gravity and quantum mechanics, explaining the Big Bang without a singularity, understanding black holes.
That's the grand ambition. It's still theoretical, of course. We desperately need ways to test it.
No experimental proof yet.
Not directly, but its theoretical power, its ability to address these long-standing puzzles, and the completely different perspective it gives us on space, time, and matter. That's why it's so important and exciting.
It's definitely a mind-bending picture, our solid, continuous world potentially being an illusion generated by these underlying quantum bits of space-time, like a cosmic pointillist painting.
It really is, and it leaves you, the listener, with a pretty profound thought to chew on. If reality is fundamentally discrete and informational at its core, built from these quantum loops, what does that really tell us about the limits of our everyday intuition? What does existence even mean if it's not based on continuous stuff in a smooth space, but on quantum information flickering through a network? It really pushes you to think about information, reality, and their connection.